Hey, am I audible? Hello?
Yes, you're audible. Yes.
Yeah, I don't know why I'm not able to share my screen. Again, trying that. Is my screen visible to everyone?
Now it's visible.
Okay, cool. Okay, so I'm gonna run this set of slides over here to Prezi. So I'll start with that. Give me a minute. So hi everyone, this is your host Jatin. Today, I'm going to present on topic building cloud native data pipelines. So like before that, I'm just gonna start by giving a quick introduction about myself. So I'm hello, I'm Jatin. I have a little over a decade of years of experience in data engineering space. I've worked with companies like PC Solution, Fidelity International, United Health Group, and now of course with BlackRock. I started off my career as an ETL Informatica engineer, then learned some couple of open source tools like Apache NiFi, Kafka, Spark, then changed my tech stack a bit and landed into a cloud native tech stack where I worked on Kubernetes, Docker, and some parts of Golang. So we were building cloud custom resource definition that called CRDs on Kubernetes, and then we also developed a data ingestion tool that was being used to ingest the data from on-prem systems to the cloud. And on-prem systems like big data ecosystem like Hadoop, HDFS, and moving data to the cloud providers, writing the connectors and stuff like that. So that's a quick introduction about myself. Uh, Going about the agenda, what we are going to discuss today in our webinar, it's really around the cloud native. What is cloud native? We're gonna discuss what do you mean by this term, what all components are there. Uh, Other part, second part, what is cloud native from a data pipeline perspective? Really, we are going to discuss about, you know, why we are talking about how, if we talk about cloud native from a data pipeline perspective, what does it look like? What do we have to change? What do we have to understand, consider, and all those perspective, all the perspective from that. Uh, Third part, how we are able to migrate a typical ETL based workload into a modern cloud native environment. uh, we are also going to discuss about an important concept that is a containerization. Followed towards the end, we will have a tech stack showcase like for a demo what exactly we chose as our tech stack, and then followed by the demo. That's it from the agenda standpoint. Let me move towards the next set of slides. Okay, so what is cloud native? Okay, so this is something that we are going to discuss first. So before actually discussing about the cloud native, let's understand two different terminologies: cloud enabled and cloud native. So for this, I think we need to first understand what is cloud enabled and what is cloud native. So typically there are two kinds of architecture people might have worked on or they might have heard of. It's a monolithic and microservices. So traditionally, we've always been building monolithic kind of an applications. We were having our workloads, our applications that are residing on the VMs or the servers, and we are running them all. So that all comes under the monolithic way of how we are designing our applications. Now, having said that, those are monolithic, but still, if we are going ahead and we are having a EC2 container on cloud and we are deploying it on cloud, uh, they would still be categorized as cloud enabled. However, they would not be a cloud native. As simple as that. So what do you mean by cloud native now? So it's very simple, something, some workload or some application that is being built to run on cloud computing environments. So we have different cloud, GCP, AWS, Azure, being some of the really good ones out there and being more commonly being used. So something, some software or some pipeline that we are building, deploying, and managing uh, over the cloud. That's really one second. It showed up here. One second. Okay. Yeah. it's really around a software that we've built and we are deployed, and we are managing that on a public cloud environment. That's basically something we would say. Now, how we are going to do that and how it is different from a typical monolithic architecture, so you would have heard of maybe saying the auto scaling part. Okay, auto scaling is quite important from cloud perspective or from container perspective. Now I'm using different terms like containers, uh, auto scaling. What exactly do we mean by that? We have a different slide for that, and we will go a deeper, take a deeper dive into that, and we will kind of understand what exactly these are. But understand, from a on a high level monolithic workers versus microservices standpoint, that we always have built a monolithic architecture based applications. We are moving towards the microservices based application, which is basically like, you have different microservices for different functionalities. It is always better to basically have that kind of an architecture where some change, you don't have to do a lot of changes, some basic enhancement, you don't have to do a lot of change. You would just pick that particular microservice, make a change, deploy it again, and you are good. That's where I think monolithic versus microservices based difference is there. Now, maybe the last part, but yeah, very important part, the API ability to basically interact with other cloud components. Typically, what happens is, we have different components. What we used to had was like we were having different applications residing on our internal servers, and then we had our internal databases and stuff like that. Now, since we are moving to the cloud, we will still be having those components, but we will be having over the cloud. Now things work quite differently there. We would not be able to kind of SSH onto the host and run be able to run the command line. We should be able to do that, but however, that is not a recommended way. Yo, so what is the recommended way? My recommended way is to use an API. So for example, your application should be able to call an API and talk to uh, talk between each other through some API or through some messaging tech. That's what primarily what I meant by that. So this is what a particular cloud native application sort of looks like, where you have, okay, the first thing is, we have to understand, we understood what is a cloud enabled and what is cloud native. What exactly is cloud native? Cloud native, something, in a microservices way, how we are going to develop our application, how we are orchestrating that, how we are auto scaling that, you know how we are integrating to other components, via API or other messaging tech. It's that basically. Okay, any questions so far? Okay, I'll take that as no. So on to my other part. What does it means, you know what does the cloud native means from data standpoint? Typically, if I talk about, we would be having people from different like organizations. They would be maybe coming from a typical traditional ETL background, where they would be using certain tool, and they would be doing ETL from one data sources to another. What exactly do I mean by ETL for a relatively lower for the folks who are joining us, like, and they are very new to the data world? ETL stands for extract, transform, and load. So organizations needs to do this kind of a extract, transform, and load very well in within their organizations, because data, it resides in the different places and it needs in the different places. So you need the data flows across the organization to be able to have as a meaningful insight. Now, traditionally, we have always been using typical ETL based tools. We are internally doing the data distribution within an organization. But yeah, now since the cloud is coming into the picture, those ways of distributing the data and managing the data are no more relevant. You still won't would like to, you still might be doing that, but yeah, if you're moving towards cloud, that may be not the recommended way. Okay, now there are modern ways of architecture that are coming into the market, that are coming into the data landscape, such as like data mesh architecture. So within data mesh architecture, since we have different data domains within an organization, so you can expose your data domain as a particular data product. So you would typically want to have a data discovery for a particular data domain, and then probably have them exposed as a typical data product for that perspective. Now, having said that, still that is like how you are managing, that is just basically how you are managing your data. You would still need to move your data that is residing on prem to the cloud. So what exactly we need to do? So when you talk about cloud, the main thing that we have here is, pay as you use. Okay. However, the workloads that we have are on prem, they must be residing on a server, and that server, uh, we would have that 24 hours with us. So that is not something that you can really put on cloud. So for cloud, you need to have it on when it is needed, something like that. Okay. So for that, you need to look into the containerization of your workloads. Okay. And containerization is something that we will discuss it further in our further slides. So just bear with me on that, and we will discuss that. Now, containerization is one way where you can have your workloads run in a way where they are only being charged, so those workloads are only running and they are only being charged when they are being used. Otherwise, they are staying quiet, and no charge for the user, the cloud user. And that's exactly how we need it in a cloud way. Other part is auto scaling. So uh, traditionally we've always seen that we do capacity planning and whatnot for our databases, for our ETL state, or for our data platforms, because we need to have a track of what kind of data we are dealing with, what are the volumes of that data, and based on that we need to have the scaling done accordingly. However, now we have tools in the market, we have technology in the market, and we have modern ways of dealing with things like that, where you're based on your volume, your uh, auto scale is already achieved, right? So at a given point in time, if you don't need the scale, you will be on scale down scale. However, if you have a larger data, typically on a month end, on a weekend, or whatever, your data pipeline or your workload should automatically auto scale. That's what we should be able to achieve through some of the modern ways of designing these. And we will discuss about the Kubernetes as well. So Kubernetes is one of the way that we can auto scale our workloads. Last but not the least, declarative style of programming is very much needed. So we can use something like a YAML, a plain YAML, which is nothing but a configuration based file, and you can put your configuration in that, and your pipelines can use that as a maybe declarative way that this is how you need to run. Typically, like this is your source and this is your target and this is what you need to do with your data, as simple as that. So with that, your time to market will be less, and you don't need to invest a lot of time in developing your workflows. So that's how basically the data perspective I wanted to give from a cloud native perspective. Okay, let's move to the slide. Okay, now uh, migrating from a typical ETL landscape. So as we mentioned that we've always got a like we might be coming from a traditional background where we might be using a typical ETL tool to do the data distribution, data processing within the database. However, now as a first point state, we need to understand what is what is our requirement. Is ETL the right approach for me, or I can go with the ELT based approach as well. So ELT is nothing like ETL is extract, transform, and load. ELT is something very similar: extract, load, and transform. Okay, as it suggests itself. So typically, what happens is we have our data on premises, and this is maybe I can give one example of my previous role where I was working. And then we had our data within our HDFS and Hive data sources. So previously we were having our jobs, our traditional ETL jobs, wherein we were using certain tools to basically fetch the data, transform it, and load it into the internal databases. The internal databases, maybe they are like Hadoop databases or Hadoop data sources or relational databases and whatnot. Right. Now we are talking about the data movement towards the cloud. Okay. So like ELT approach does make a lot of sense now, because whatever data you have, you are just ingesting it into your what you say S3 buckets or and what storage buckets and whatnot. And then based on that, so your extraction is done, your loading is done, and then you can maybe do some transformations on top of it. You can use some of things, some of the tools like DBT. DBT is something that can create models on top of that, and then based on that, you should be able to have your virtualized layer of data on the cloud, and do the data distribution accordingly. So that's where I think, but having said that, it is all particular. uh, this approach is certainly someone, so people would be able to understand if it's relevant for them or not. So just choose what's best for you is what I would say. Now other part is, since we are talking about the cloud, we need to have some warehouse on over the cloud. So we have multiple offerings out there, like Snowflake is being something that is being used across the organizations, and it's being used and preferred so much these days. Other than Snowflake, we have other tools and technologies as well, like GCP provides BigQuery, then AWS provides Redshift, Azure provides Azure Data Factory, something. So we have a lot of cloud data warehouses offering out there, that someone can should be able to use them and probably move their data towards the cloud. Then the last part and the most important part, writing pipelines, how we are going to write the pipelines. Certainly we are not able to write the pipelines like how we used to do that traditionally. So we need to understand if we are going with the complete cloud native based approach or open source based approach. When I say cloud native based approach, there are different uh, tools and technologies that are provided by the public clouds itself, so you should be able to do that. However, the one that I would suggest is, you take a cloud native approach, but be technology agnostic. What I really means by that, do maybe we can take tools and technologies from a particular cloud, but it should be like whatever solution we develop should be technology agnostic. I mean, we should not have a dependency on any of the public cloud. Certainly that is something that we are coming out from, and we don't want to get into again, probably is like that. Now when we talk about the open source tools that we can use to write the data pipeline, certainly that that should, some of it should be able to, you should be able to understand by our demo itself, like how we can write the data pipelines through open source tools. And certainly that is something that we should be able to demo through our should be understand through our demo. That's towards the end of the slides. Okay, that's around the migrating part from a typical traditional ETL landscape. uh, Let me just take a pause here. I just wanted to check, do we have any questions that maybe I can take right away? Okay, I'll take that as no again. No problem. Okay. So next, this is basically the most important concept when we talk about the cloud native. Okay. So as we mentioned, as we discussed, pay as you use. So certainly this concept came from when cloud started, cloud enablement started, which means that previously we were having our applications, we were having our workloads, but we were actually maintaining a proper server for them. Okay. So we came all the way from maintaining our own servers towards one server that is having different VMs. you know VM is nothing but basically a slice of a particular server that is being used for a particular application. Now this is a further evolution towards in that journey. So we came from a physical server to a virtual server, which is nothing but your VM. Now from your VM, we are saying that we can have your containers pinned up. Okay. What are containers? Container is basically, think of it like, maybe people can correlate it. I mean, I'll just basically use a very layman term. It's like a scaled down server for your particular workload. Scaled down. So it's on a microservices based architecture, right? So if you see this image out here, so you have your infrastructure layer, and infrastructure could be, your bare metal, your physical infrastructure, or maybe virtual as well, no problems. But your basic infrastructure, your server and all. And over that, you have your operating system. Your operating system could be your Windows operating system or your Linux operating system or whatever. So these are the bare basic infrastructure that you need to run your workloads. And so far we know, right, we already are running our workloads on these operating system. We are writing our scripts, we are writing our code or whatever to run on this operating system. Now we have another layer called Docker, or this is basically a Docker related image, but think of it like a container, right? Your container can host multiple applications, and it's basically like a scaled down version of your VM, right? Further scaled down, I would say. Also, like, what benefit that we get out of it is, we can have all the dependencies that are taken care of. So for example, if I talk about, just take a small assignment, like you write some script, try containerizing it. So the first thing that you would have to do is you would have to first take care of the dependency part. So the Docker file that we create, uh, maybe a typical Python Flask API. Let's talk about that. So that Python Flask API is taking care, like it's having a dependency on Flask framework, or maybe HTTP framework, or maybe whatever framework, NumPy, Panda, whatever. So those are basically like a dependencies of that particular API, or that particular script. Now that dependency is basically written in a Docker file, and that Docker file will be like packaging all of your dependencies alongside your application, right? And that ways, and that ways, I think you would have your deployment probably same like in non-production and the production environment. So you might have seen issues saying that, okay, on my non-production environment, this is working, however this is working, and on production it is not working. Why it is like that? Because dependencies are usually missed. Okay, there's no proper way of taking care of the dependencies. We have modules, we deploy packages, we deploy modules, and then we might end up kind of missing certain modules, and that's where the issues came in. However, with the containers and things like that, you would have all the consistent operations. You would not have a problem of missing a package or missing a dependency, and all of that. And uh, with that, it's definitely a better and a modern way of application development, which is having a less overhead. And as said, it's a containerization. It's a most important concept of cloud native way. So the portability is also there, means the same container that you have, you would be able to run it on your local system. You would be able to run it on the Kubernetes based environment. You should be able to run it on a cloud environment. You should be able to maybe create an image and run it serverless. So everywhere it will have a more predictability in your workloads. So that's where I think this is basically coming as the most important concept for cloud. Now this is done. I again want to maybe take a pause if someone have any questions or they want to ask anything.
We have questions in Q&A section. Please
Okay.
check there.
Okay, one second. What exactly is auto scaling? Okay, so auto scaling is, you, for example, you have your one question I have seen from Sanjay. Okay, and maybe I just want to take this question first. uh, what is auto scaling? So for example, you have your workload. Okay, that typical workload, you have your script. Okay, and that typical script processes some data. So over the weekdays you have your data, and that is coming maybe 10 MBs of data or whatever, and your workload runs. At some point in time over the weekend or some month end or anything of that sort, you get your data in GBs. Okay, and your VM or wherever you are running your workload, it's not meant for that. It is not having that much RAM, or it is not having that much capability or resources for that matter. So there the auto scaling concept arises. So Kubernetes or these modern tools and technologies provide you ways to auto scale your deployment. So for example, if for some time you get a larger amount of data, or your application needs more resources for running, you should be able to take that. Your application should be able to auto scale that. Having said that, there are different kinds of scaling. You have typically horizontal scaling is something that is being preferred across, but this is something that we can easily achieve through the cloud native ways of application development. So horizontal pod auto scaling is something that we might want to maybe Google and understand how that is something we can achieve. So I've got a question from Kisley. What is the difference between containerization and virtualization? So containerization is basically around. So hi Kisley. So Kisley, your question is very well valid. So containerization is basically like you similar way you have your script that is processing certain data. How we are going to manage those workloads? Okay, so what you do is you package your complete script. Your packaging means your dependencies, your way of execution, how you are maybe orchestrating that everything. You can maybe just package it and run it as a container, as an individual container, and that individual container will be like your construct to kind of execute your particular workload. So this particular, like, and the advantage of that is you should be able to run that over any cloud or any local system or anywhere. I mean, it will be consistent across. However, virtualization is something different. You know, virtualization is you have your maybe virtualization I can take it in a way that you have your. Okay, let's talk about this particular image that we have here. Okay, so it's a virtualized layer. Okay, so virtualization is basically like you're sharing your workloads. So application A, B, C, D, E, F, it's virtualized on a host, operating system, and infrastructure. This piece of infrastructure, this is what the virtualization is. And to achieve that, you have to containerize it. That's what it is. Okay, so I think I have answered Deepti's question as well. How container, so we've got a question from Raja as well. How is a container managed within different environments such as dev sit? So as mentioned, container is container. I mean, it will run in a consistent way across the environments. So you should be able to package it and make an image out of it. And with that image, you should be able to deploy it on any of the environment that you want. So basically it's like bundling or uh, you know I would say containerizing your application, bundling your application, and then by bundling you create an image out of it, and that image can be deployed anywhere. So that's how you be consistent across throughout your dev set or any of the non-production or production environments. I hope this answers your question, Raja. Okay, so let's move further. Now actually this is supposed to be the second slide. Let me first talk about the demo what I'm going to perform right now. Okay, so this is a small demo that I've prepared, and I don't have any cloud subscription because this being my local setup, my personal setup, I don't have a cloud environment, so everything would be running on my local Mac. And think of it like a just another VM, Linux VM. So if it is running here, it will be run. It should be able to run anywhere, no problems at all. So what we are going to do as a part of the demo, so we will be doing a file data movement. Okay, and what we are going to use a tool called as Benthos. So Benthos is nothing but a Go based, library for doing the data streaming. Now, how we are going to do that? We are going to deploy that on Kubernetes, and we are going to have a workflow based deployment on Kubernetes. So that file consumption we will do, and the output we will have it as a standard output, something like a stdio, stdo out, something like that. But that is, like I said, it's a cloud native workload, so everything is pluggable. So if you want to just remove the standard output, you can just replace that output with any of the cloud output that you want. No problems at all. Now, going a step back, what kind of tech stack we have used? We have used Kubernetes for container orchestration. So the Benthos that we've used, it was not there. There isn't any packages or guidelines available for Kubernetes. However, I was able to deploy that on Kubernetes and be able to run it through container because it was already containerized through a Docker. So Docker way I ran it, and then I was able to put that on Kubernetes. So Docker is definitely important part of it because first thing is containerization of it that I did through Docker itself. Now Benthos I spoke about. Benthos is nothing but a uh, stream processing library built in Go. So if you want, you can just go to benthos.dev. It's an open source. So I just used it, and that's what the input file and output file looks like. So for out right now, the output is something stdio, probably like whatever output you want, you should be able to do that. So you just go here, components, outputs. So for example, you want to move your data to AWS S3. So this is what the output section that needs to be replaced. And of course, you need to fill out your AWS bucket details, your max in flight number, your byte size and things like that. And of course, before even setting that, you have to set up all your, uh, you know, auth related permissions, right? So, okay, 1 second. I think I went to the wrong slide. Yeah. Okay, so this is basically the tech stack that I've used. And now I will just move towards my demo. So let's see how happy demo gods are with me today. Okay, let me open my, okay, 1 second. Let me remove my old pod. So right now on my machine, I have a mini cube. Okay. So if you would just want, I have set up everything over this GitHub repo, and I'm going to ask to this repo to be shared. Typically, like what exactly we need to do as a part of this demo. And this is something that I already have set up, and I didn't wanted to take a risk to kind of destroy everything and rebuild it because it takes time, and it is not something that I wanted to take risk. So you can just follow these instructions and should be able to run the demo setup on your system as well. Okay. So what exactly I did, I basically set up a minikube. Minikube is a local version of Kubernetes. So you can typically just deploy minikube, and you should be able to run your Kubernetes cluster on your VM, on your machine, on Windows, on like whatever OS you want. So the instructions are also here. So these instructions are nothing but, I don't know how to, 1 second. Okay, and instructions are also here. So this is like minikube documentation. So based on whatever operating system you have, you should be able to just deploy minikube, and you should be able to just run it. how we are going to start your cluster. So once you are able to download the binary and set up and all, so you should be able to just do a minikube start, and with that I think you should be able to have your uh, Kubernetes running, typically how we have done here. So you do a minikube start. These are the some information messages that you get. Once you have done, kubectl is now configured to use minikube by default. Then your minikube is all up and running. And of course, for that you need to have kubectl command line as well, and Docker as well. So Minikube is nothing but a scaled down version of Kubernetes. However, it runs on Docker itself. So it's essential for you to have Docker and kubectl installed, precursor to it. I just realized that I haven't mentioned that. I will edit this README and I will mention that as well. Now, first thing is you have to just clone this repo. Okay, so git clone, and you should be able to just clone it. And with that, I think you will be having certain configuration files with you. So certainly, these are something that I might want to take just few minutes to talk about. So these are like config maps of your Kubernetes. Okay, so this is like a config of config map. Okay, and here I'm just mentioning what I mentioned here was like Benthos config. So this is just nothing but your Benthos config. So you have your input. Okay, and here in my pod, like my CSV file will be mounted, and then this would be like my output. That's it. So this will be mounted on my Kubernetes pod as a config map. Config map is nothing but a construct that allows you to uh, give certain configs. Typically, like for software engineers, we have config parser, right? How it works. So you should be able to parse the configs out of that config parser. And same way, through config map, you should be able to. It's a construct through which you should be able to have the config like injected into a pod, a Kubernetes container, probably like that. Now, having said that, pod and container are also two different things. But yeah, just understand that as a pod as your container. That's it. Then one that is your config map. Then this is your data config map. Again, I want this is not the right way of having data mounted onto your pod. However, just this like from this demo standpoint, I have mounted this config map just to say that this is my data, and this basically would be my data that I'm gonna process through my Kubernetes workload. Okay, and from here the data, my main data starts, and this is all the content of config map kind. And finally, this is basically my most important config file, the pod YAML. And you guys remember we discussed about the declarative approach of writing your workloads. This is exactly what we discussed that time. So it's a YAML file. It's a declarative way of you putting together, telling your application that okay, this is what I want. So this is my pod kind of name, pipeline pod, and then I don't want it to be restarted after it is completed or failed. And this would be my container name. This is my image name that it should take. So the image should be there on your system beforehand. So typically, if you do a Docker pull and that image name, you should be able to get that. So save image ls. So this is the image that I used. So before that, I think as a precursor, we would have to pull this image too. I will add that onto my README. So once you have this image embedded into your local system, you should be able to use it. And that's where I think I just gave the name. So JFL Benthos is basically the Benthos, the stream processing library image. So that is the name, and this is the latest tag. So JFL Benthos :latest. And within my Benthos container, I will run this command line, which is nothing but a Ventos command line. If you take a deeper dive into the Ventos, you should be able to understand how we need to run the workloads. Now, basically the volume mounts, volume mounts are nothing but the config maps that we discussed about, the data and the config map. So, so that is something that you have to on the fly dynamically mount on your pod. So this is how you do that. Okay, just don't think more any more towards it. Think of it like a config that you are mapping onto a Kubernetes pod on the fly. That's about it. You might have to take a deeper dive in terms of understanding what config maps are, how they are relevant towards my data flow and my application, so and so forth. So this is basically the pod.yaml, and this is essentially, you can say, as the pod definition. Pod definition for my workload. Now I already have everything here. So this pod.yaml I have here. So I just need to do kubectl apply -f YAML. And you'll see that the pipeline pod is created. So if I do kubectl get pods -w, okay, this is already completed. So this is my pipeline pod. I will just do kubectl logs. So with that, I think with -w, essentially you should be able to see your pod first coming, fetching the actual image, and then running and then completing. You should see the status right from starting to running till completed. Typically how I have mentioned it over here. In the readme also I have mentioned it. See, it came, container creating, it changed its status into running, and then it completed. But yeah, till the time I did a kubectl get pods -w, it was already completed, so it didn't capture the other two statuses. Now I see that my workload is already completed. Now I would just do kubectl logs and then pipeline pod, and with that I should be able to see all the records that are in my config file as a standard output. Essentially right now it is basically the standard output that I chose as an output for me, because I didn't had any other data sources to basically ingest the data. However, you should with your config pointing onto the right data source, you should be able to map your ingestion accordingly. This is what the pipeline actually data cloud native pipelines actually look like. So that's up with my demo. I don't have anything further. So you guys have any questions that maybe I can take? Let me open the Q&A. Can we process Kafka messages with Benthos and stream it out? Yes, absolutely. I think that's the very nice question. So let me open the Benthos here. So you see input and outputs, right? So in input, you see that Kafka is already one of the input. And I did that in my past, in my career. So with that, I think you should be just able to replace your input with the, this particular section. You have to, typically within your address, you would have to add your broker addresses. So you have your broker or you have your brokers. You can maybe just do a comma separation and you add your brokers here. And then what is the topic that you want to move your data into, ingest your data into, and the consumer group. With that, I think you should be able to ingest your data or read from the data or uh, ingest into as well. So this is the input part. So in output part also you should be able to see it. One second. Input, output. Output also you should be having a Kafka. There you go. So this is the output section. You can stream it out, no problem. I hope that answers your query. Okay, what is the difference between pod, container, and nodes? Okay, so Nodes are basically your uh, nodes on or your VMs where your Kubernetes is running. I think I should be able to get something for you. One second. Get nodes. Okay. See, if you do a kubectl get nodes, you should be able to see your nodes here. Okay. Right now, it's my VM. It's my Mac that I'm running. So I'm just seeing this minikube running on one node, and that is running my control plane and master two. Typically in a production environment, you should be having more than one here. So one would be like control plane and another would be like master and then slaves. So that's basically what the node means. And on your nodes, you have your containers deployed. Now pod and container, these are the two different things also, and same thing also. Like if you can just go on Google and read a bit more about after you go through the Kubernetes, that would be better. But yeah, essentially a pod, maybe if I'm not wrong, a pod can contain multiple containers, probably, if I think so. So for example, like you have one way, I think I'm not getting that. So if for example you have your workload and you want to push your stats to Prometheus or something, you have a sidecar container as well. So on one pod itself, you have multiple containers running, and that's the difference between container and a pod. So your main pod, your main container will take care of your workload, and your sidecar container will take care of the pushing the stats to Prometheus or any other monitoring tool for that matter. So that's the high level difference between pod and container. I hope it doesn't confuse you, but if you're confused, if you're still confused, I would say read a bit more around um, Kubernetes, and you should be able to understand that part. Please share the GitHub link. I'll certainly would do that. Could this be run as a deployment rather than a pod? Yes, definitely. This can be run as a deployment as well. So like for me, I thought, okay, let me just create a pod and then go with it. That's about it. But yeah, essentially, if you're going for production implementation, it should be a deployment. And that's where I said this is not the best solution for production. This is just a working prototype just to demo the functionality. However, if in production environment you should actually make a deployment rather than creating a pod on runtime and getting away with it. However, on production environment also, you can have a pod, create a pod and destroy it on runtime. For that, you need to have a CRD for that, custom resource definition that should manage your life cycle of pod. If you don't have that, if you don't have something like a Argo CD or some resource that should be able to manage your pod life cycle, you should run it as a deployment. I hope that answers your question. Okay, I don't see any other question now. So, okay, I'm just stopping my stopping sharing. Stop sharing now.
Thanks a lot, Jatin. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct such more sessions with you in the futures. LinkedIn profile of the speaker is posted in the chat section. I hope you guys have filled in the feedback poll. If not, I request you to fill in the poll about feedback as it will help us to conduct more such sessions. If you wish to conduct a webinar or are facing difficulty in registering, connect with us at editor@analyticsvidya.com. The recording of this session will be available within 2 days on our YouTube channel. We will be back with another session of the data on 27th Jan, as the link is in the chat section. Till then, bye bye and keep learning.
Thanks everyone. I hope this was useful to you. If in case any questions, feel free to connect on LinkedIn. No problems. Thank you. Thanks all.